What's up, guys? This video is going to recap our weather project, which we've covered over the last 3 days in class. I'm going to request the data, get it back, interpret it, and then the last step was going back to the beginning and improving how we get it in the first place. So let's see if we can do that. I'm going to from urllib.request import URL open, and then we're going to use it with URL open. We'll prepare the URL in a separate line as R. We usually call it R for response, and then we read it. So what's this URL? We're going to request data from an API called OpenMedio, which has a very nice system where you can get weather, precipitation, temperature, future, current, or even the past, and it looks like this. I'm going to copy what I've prepared in another file here, and so we're going to have something like this where it's got the URL and then the query at the end is like key value pairs. Latitude equals this, longitude equals this, and so on. And I'm going to make a little dictionary because it's too much for one big old line. So we're going to go latitude is a variable to be filled in a second. Longitude is same thing. And then we're going to ask for the current weather. We're not going to ask for future or past. We're going to say, hey, give me the temperature. They call it 2M, which is like 2 meters above ground, I guess. And then weather code, which is a description of rain, sun, fog, whatever. We're also going to ask for the units to be Fahrenheit, because default is Celsius, and that's fine, but it's not what people expect. For example, this little weather widget on Windows in the bottom left corner of my screen says 55 sunny, which is exactly the kind of thing I want to get in this program. So there's our parameters. Let's put it in a URL. And honestly, there's probably a built-in function to do this, but we'll do it. Let's say query equals, we're going to go like, we're going to call it K and V for key and value. And that's an F string for KV in params dot items. And then we're going to put the whole thing in ampersands. So let me show you what that looks like. In their example, it's like latitude equals this, and longitude equals this, and current temperature, etc. This is a very common thing in URLs, which is why I think there's probably a built-in function, but it's fine. We got it. And I'm going to put that in a function because it's kind of an annoying detail. I want to wrap it up and forget about it, so let's call it prepare weather URL, and it takes latitude and longitude to be determined elsewhere. And I guess we'll say return right there. So let's say prepare weather URL, and in a minute we're gonna get these dynamically and find the latitude and longitude, but for now let's just hard code some numbers. I'm in Jeffersonville, Indiana, and they have coordinates on Wikipedia, but they're the ugly, like, degree. I think they call them minutes and seconds or something. But we want this decimal. Also ugly, but in a different way. So I'm going to copy that over here. And then let's try that. Let's go print. Say, hey, OpenMedio, what's the weather for these coordinates with these properties? It's a JSON. Look at that. So we're going to go JSON dot load s, load string, but we got to import. So we're going to go import JSON, and then it's going to look almost the same, but now this is a real Python object instead of just a string, and so we can do things like access a key. So what do we got? Latitude and longitude. It's just giving back mostly what we gave them, but it's saying, hey, the weather is measured in this slightly different location, which might matter. Time zone, elevation, we're not worried about that. We're looking for this stuff. So we're getting inside of the current dictionary. Let's say weather equals this thing, and then we'll go temp equals weather, current temperature to M, and then we'll say code equals the same thing with weather code. And then let's print those guys, temp and code, which is the two things we wanted. Of course, you can get a lot more, and you can say more about now or more about the future, but let's say the minimum, just like my little weather app down in the bottom left corner of my screen. So 50 degrees, 0. What is 0? That's the thing with the codes, is they have this very complicated system over here, but if you're getting a description of the weather, they give it to you like this. 0 is clear sky, 45 is fog, 53 is moderate drizzle, and this chart, I don't know, it's probably 100 years old, sent through telegraphs or something, but it's a little bit annoying, and I wrote some code to translate this into this, which is a bit nicer. So I gave you guys this file, weather codes JSON, and hey, we already know how to load JSON because we've been doing that with all the APIs. So let's load that up. Let's put it right at the top because it's going to be like a constant, like something that we prepare at the beginning of the program, and it never changes. So I'm going to go with open weather codes.json as f, standing for file, and then I'm going to put this in all caps because, like I said, it's a constant. It doesn't change. Probably hasn't changed for decades. So we're going to go json.load. It's not load s like the other one because that was a string. This is a file, so we give it f. And so now for the weather, let's call it description of the weather is weather codes, looking up the code. And then we don't print the code anymore, we print the description. Let's try that. Yeah, okay, so there's a problem, which is that JSON uses strings for keys. However, it uses strings or integers or booleans or floats or arrays as values. So when we got the response of the weather, it said, oh, 2.4 or, you know, code 0 or whatever. And it very reasonably converted that to an int. But we don't want it to be an int if it has to be a key in this guy. So let's say, okay, fine, stir of that, and then beautiful, 50.8, clear sky, exactly what we want. And you'll notice this is different from my Windows app. It says 56, so maybe they're different times or slightly different places. Maybe, you know, different part of the city is being measured. So, great. There's a problem, which is the latitude and longitude. What if I want a better location that's where I am now and not just whatever Wikipedia had for the city? What if I want to find other locations, like what's the weather in Paris? What's the weather on the Empire State Building? Well, it would be extremely annoying to actually look up the latitude and longitude of those things. Can't I have the computer do it for me? And the answer is yes, with another API. There's an API that can do what they call geocoding, where you give it a place and it gives you info about the place. So I found one called Nominatum. I don't know if it's the best or the most popular, but it seems to work great. And what it does is it takes pretty much any search terms, like you can give it a city and state or street, or you could even say like Central Park or, you know, United Center, and it'll get the best guess of that thing. In fact, it'll give you a list of multiple. So let's say I'm going to use their thing, and I'm going to make another little function to prepare that URL, just like with the weather, but this one's going to be, we'll call it location, and it'll take, I'll call it search string. So this will just be like, we type some words. We type, you know, Louisville, Kentucky, or we type Los Angeles, California. Okay. And then let's prepare that. Let's say, okay, search string equals input, search for location, and then we'll do another one of these guys with open blah blah blah, except this one it's going to be prepare location URL as R, and then we do something with it. In fact, let's go like print r.read again to see the basics. So what do we do in here? Well, let me grab the URL from another window here. So it's from OpenStreetMap, which is like people can submit changes to a map. Oh, here's a new name, here's filling in blanks, whatever. And we're asking for JSON, which is probably the default, but they showed it on there in an example, so great. And then this query is a little bit different from here. It's not key value pairs with the equals, it's just words. So if you do like a Google search and you say like the Lord of the Rings, then it'll go pluses in between them. And that's what we want here. We want pluses in between them. So I'm going to take the search string and go query equals search string dot split to split it into words, and then I'm going to plus dot join. Okay. Now I could go search string dot replace and then replace the space with a plus, but I'm slightly worried about what if there are two spaces in a row, what if there's a space at the end. I don't know if this can handle that, but I know that the split join can, because it'll always be exactly one in between them. Sounds good to me. And then, is that enough? Maybe that's enough. We'll see. So let's go, yeah, let's try that. I'm going to go full screen now that I have more code. Let's say Jeffersonville, Indiana, because we know what to compare it to. If the latitude and longitude is something like this, then we know we're on the right track. Okay, yes, it is JSON. It is pretty similar to what we've seen before, but you'll notice it's in a list. It's in an array. They would call it an array in JSON. So it has brackets, because you might get more than one. Like if I said Paris, well, there's more than one. There's Paris, Texas, and there's Paris, France, and there's Paris, Kentucky. So it's not just one, it's a list. Even if it is just one, it's still a list. So if you guys were watching in class, I showed how to do a little loop through and say, is this the one you meant? No, how about the next one? Is that the one you meant? I'm going to skip that here and just take the first one on the list, assuming that the search terms were specific enough. But if you want to stick with that or add that or change it to whatever you like, that'd be wonderful. So let's say, okay, we got that, we got the thing. I'm going to go location equals json.loadus, this thing, but remember it's a list, so let's just peel off the first one. So I could do index, but I'm an index hater. Instead, I'm going to do that and say location and the rest, which we're now throwing away, but we could use it in the future. We could say, oh, give it the name rest, and then look through the rest if you don't like the location, etc., etc. And then let's print location just as a test. Let's say Jeffersonville. with no Indiana, because there are lots of Jeffersonvilles, but I think we'll still come up first. Yeah, great. How are we going to show that? We're going to take this guy, display name, and so I won't do a whole loop where it says, is this what you meant? And then look at the next one. But I will still show it as a way to confirm, like, if it showed Jeffersonville, Georgia, I would see it and go, okay, maybe I run the program again with more specific search terms. Okay, so let's go print location display name. We'll just print it and not actually do any logic with it, but we will take the latitude and longitude, which is going to be location, and they call it lat and lon, just like I did, so it's the short names. Lat, location, lon. So theoretically, this will set us up for the next part, right? Like if I take this and search for it, then it'll tell me the weather in wherever I searched for instead of whatever numbers happen to be hard-coded in there. Can I fit the, yeah, I can fit the code on the screen if I zoom out a tiny bit. Let's say Paris, France, and then it'll tell us like, oh, is this the one you meant? It's not asking, but at least it'll confirm. And then, hey, they're doing great. What if I just put Paris? Well, that's still enough. But what if I say Paris, Texas? Hey, that is not right. That is not the one in Texas. That is like some Hungarian thing. Sometimes you might have to be more specific. There we go. Amazing. So this program does three things, right? We search for the latitude, longitude, we use the latitude and longitude, and then we interpret the result by looking it up on this guy. And that's pretty good. It's 30-ish lines. It fits on the screen, but it's doing some complicated stuff, and I'm happy with that. Like I said, you could add more. You could say, give me the forecast for the next few hours. You could say, look through all the possible matches and not just the top one. You could say all kinds of things, building from this foundation. Thanks.